In this video, let's focus on cheese and catch problems. If you ever looked at a question like this on an exam and felt like your head was spinning, you are definitely not alone. It looks like you need to juggle a ton of different variables, but there's a simple trick to solve this whole thing in under 10 seconds. Let's break down exactly how this works so you never have to panic on this setup again. So here's our scenario. We've got a motorcycle cruising past a parked police car at a constant velocity v. At that exact moment, the police car starts chasing it with a constant acceleration. Our job is to find the exact expression for the time it takes for the cop to catch up. First of all, before we dive into the details, let's talk about the master key to unlocking any cheese and catch problem. No matter how complicated the setup is, the entire physics boils down to just one thing: finding the mathematical relationship between the displacement of two objects. Sometimes one object has a head start, or they start from different places. Your goal is always to write down an equation that bridges how far the first object has traveled with how far the second object has traveled. Something like SA plus D equals SB, where D is the head start. In our specific scenario, the police car starts at the exact same spot as the motorcycle and catches up to it at another exact spot down the road. Because they share the same start line and the same finish line, their total displacement must be completely identical. So we have S1 equals S2. So let's write out the displacement formula for each one separately. For the motorcycle, the velocity is completely constant. There's no acceleration. That means its displacement S1 is just the velocity multiplied by time. Now, what about the police car? Since the police car is moving with constant acceleration, we need to use the master kinematic equation for constant acceleration motion to find its displacement. Let's write down the kinematic formula as 2 equals ut plus 1 over 2 at squared. Because the police car starts completely from rest, we know its initial velocity is exactly 0. This completely wipes out this entire first term. So because of that, this whole expression simplifies beautifully to just half of the acceleration multiplied by the time squared. Here's where our displacement relationship makes this easy. Since the displacements are equal, let's set them equal to each other. Vt equals half of a times t squared. Next step, since we want to find the time when they meet after the starting time, we know t is not 0. That means we can divide both sides by t to clean things up. This leaves us with v equals 1 over 2 at. Now we just want to isolate t. So multiply both by 2 and then divide both sides by a. We get t equals 2v over a. And look at that. It matches option C perfectly. And that's literally all there is to it. Once you realize that, the core strategy for any cheese and catch problem is simply mapping out the relationship between their displacement. The math practically solves itself. If this cleared up some confusion for you today, do me a quick favor and hit that subscribe button. It helps us a ton. See you in the next one.